Good morning, everyone. So today we will be doing the last topic of the syllabus, same MGF for continuous functions. So again, what we have done till now, moment generating function is defined as MA of t or M0 of t, which is expected value of e raised to t into x minus a or x minus 0 or x minus x bar. There are three types of that: MA of t, M0 of t, Mx bar of t. So if a is there, x minus a; if x bar is there, then x minus x bar, etc. And if it is a discrete random variable, we will write summation. And if it is a continuous random variable, then we will have integration. And then actually while deriving this d by dt of MA of t, etc., we had expanded e raised to t into x minus a. Okay, then we have got that. So remember this part here. Sometimes we may have to make use of this definition also to calculate the moments. Coefficient of t raised to r upon r factorial is the rth moment about the origin or about a point, or mu r dash is equal to coefficient of t raised to r upon r factorial. Either it is a or 0, and otherwise if we expand mx bar of t, then we will get mu r, which is again the coefficient of t raised to r upon r factorial. This is the third definition we had, mu r dash is dr. This we know it. Sometimes what happens is you may not be able to differentiate with respect to t because the function may not be defined for t. So in that case, you may have to use this definition to calculate the moments. Coefficient of t raised to r after expanding inside the integral or inside the summation, whatever is the coefficient of t raised to r upon r factorial, that is going to be mu r dash. So from that we can calculate mu1 dash, mu2 dash, mu3 dash, etc. And similarly, when we calculate about the mean, then the coefficient of t raised to r upon r factorial will become mu r. So just remember this, we know already, we have done so many problems based on this. So remember this concept. If we cannot apply this formula, then the coefficient of t raised to r upon r factorial is to be used to calculate mu r dash or mu r. As I told you, if it is x bar, then mu r will be the coefficient of t raised to r upon r factorial, and the other form. If you're able to differentiate, you differentiate, there is no problem. Sometimes what happens, when you put t equal to 0, the function may not be defined because there is a possibility that t may be there in the denominator. And when you put t equal to 0, the function may not be defined. So in that case, you might have to apply coefficient of t raised to r upon r factorial or any other method of calculating the moments. So take the first problem. So till now, actually, we were doing all discrete random variable. Now we will do continuous random variable. A random variable x has the following probability density function. F of x is equal to 1 for 0 less than x less than 1 is equal to 0 otherwise. Find the MGF, mu r dash, mean and variance. सबसे पहले हमें MGF निकालना है. To calculate MGF, we have to, again, there is nothing is specified that you have to calculate about a point or about the mean. So directly we can calculate about the origin, or we can calculate M0 of t. So M0 of t will be equal to expected value of e raised to t into x. And I told you, this x has to be capital inside the expected value, and when you take summation or integration, it is going to be small x. So now since f of x, we are given a continuous function. So how to identify whether it's a continuous function? Here the limits are 0 less than x less than 1. इसका मतलब होता है कि x takes all the values from 0 to 1. That means 0.0. It's a continuous function. 0 से लेके 1 तक जितनी भी values है, decimals में, fractions, whatever values we are having between 0 and 1, x takes all the values. That is why it becomes a continuous random variable. So for continuous random variable, expected value will become integration, e raised to tx into f of x. If you are given a discrete random variable, then instead of integration, we will have summation. Summation e raised to tx into p, probability. Here we have f of x when we have a continuous function. So now we have to substitute for the function f of x and integrate and get m0 of t. Now f of x is defined in 0 to 1. So we will have the limits of integration as 0 to 1. F of x is defined as 1. So we can write e raised to tx into 1 dx. The variable is x. So we have to integrate with respect to x. So we will get e raised to tx upon t between 0 and 1. Apply the upper limit, lower limit. Variable is x. So applying x as 1 and x as 0. We will get the m0 of t as e raised to t minus 1 upon t. So m0 of t is 1 upon t e raised to t minus 1. Okay, so now we are having t in the denominator. तो ये हो गया हमारा mgf. अगर हमें म्यू आर डैश निकालना है तो नॉर्मली हम लोग क्या करते थे, इसको डिफरेंशिएट करते हैं डी बाई डी टी ऑफ एम जीरो ऑफ टी एट टी इक्वल टू 0. लेकिन यहाँ पे अगर हमने डिफरेंशिएट करने के बाद भी टी तो डिनोमिनेटर में ही रहने वाला है. We will get t square in the denominator. So we will get the answer when we put t equal to 0, the whole term will become infinity or it's not defined. इसीलिए we cannot apply the formula as d by dt of. तो हमें क्या करेंगे, either we have to use the expansion, calculate the coefficient of t raised to r upon r factorial, or we can do is on the normal method of calculating the mean. जैसा हम लोग विदाउट एमजीएफ जैसा करते थे वैसा वो मेथड से भी कर सकते हैं. तो आई विल शो यू हियर कोएफिशिएंट वाला मेथड. सो वी आर हैविंग the function was 1 upon t e raised to t minus 1. So e raised to t के बदले we are going to make use of this expansion. So e raised to x is 1 plus x square by 2 factorial plus x cubed by 3 factorial. I told you the two expansions we are using every time. One is e raised to x and other one is 1 minus x raised to minus 1. Okay, these two expansions we are using it in this moment generating function. तो हम substitute करेंगे e raised to t के बदले. We had got m0 of t as 1 upon t into e raised to t minus 1. तो e raised to t के बदले ये पूरा expansion यहाँ पे आ जाएगा x के बदले t. So this is e raised to t minus 1. And outside we have 1 upon t. If you simplify, 1 and minus 1 will get cancelled. We can write 1 upon t, t plus t square by 2 factorial, t cubed by 3 factorial, plus etc. Take 1 by t inside. So we will get 1 plus t by 2 factorial, plus t square by 3 factorial, plus etc. Okay. So now we have got m0 of t as some series. The coefficient of t raised to r upon r factorial is mu r dash. Okay. So coefficient of t raised to r upon r factorial. Okay. अगर मैंने यहाँ पे t raised to 1 upon 1 factorial लिया, तो what is the coefficient? What is the coefficient of t raised to 1 upon 1 factorial? It is 1 upon 2, not 1 upon 2 factorial. Because 2 को हम लोग लिख सकते हैं 2 into 1 factorial. है ना? इसको हम लिख सकते हैं 2 into 1 factorial. तो ये हो जाएगा t upon 2 into 1 factorial. So t upon 1 factorial का coefficient होगा 1 by 2. इसको हम लिख सकते हैं 3 into 2 factorial. So coefficient of t square upon 2 factorial will become 1 upon 3. So what is the coefficient of t raised to r upon r factorial? टी रेज टू 1 का फैक्टोरियल है 1/2, टी रेज टू टी स्क्वायर अपॉन 2 फैक्टोरियल कोएफिशिएंट है 1/3, so t cube का हो जाएगा 1/4. So what is the coefficient of t raised to r? It will become 1/r plus 1. ये क्लियर है? t raised to 1/1. अगर हमने 2 फैक्टोरियल को 2 into 1 फैक्टोरियल लिखा और फिर t अपॉन 1 फैक्टोरियल का कोएफिशिएंट हो जाएगा 1/2. 3 को हमने लिखना है 3 into 2 फैक्टोरियल, मतलब टी स्क्वायर अपॉन 2 फैक्टोरियल का ये हो जाएगा 1/3. टी स्क्वायर है तो 1/3, टी है तो 1/2, टी क्यूब है तो 1/4, एक ज्यादा है, इसीलिए टी रेज टू आर का होल टी रेज टू आर अपॉन आर फैक्टोरियल विल बिकम 1/r plus 1. क्लियर दिस पार्ट? हमें टी रेज टू आर अपॉन आर फैक्टोरियल, अगर ये 2 है तो हमें इसको 2 फैक्टोरियल के फॉर्म में लिखना है, अगर ये 1 है तो 1 फैक्टोरियल के फॉर्म में लिखना है, उसके अलावा जो भी टर्म्स दैट इज कॉल्ड एज ए कोएफिशिएंट. अगर टी क्यूब है तो टी क्यूब अपॉन 3 फैक्टोरियल के अलावा जितने टर्म्स है दैट इज गोइंग टू बी द कोएफिशिएंट ऑफ टी रेज टू 3/3 फैक्टोरियल. तो यहाँ पे कोएफिशिएंट ऑफ t raised to r upon r factorial is 1/r plus 1. Clear this part? कैसे लिखा हमने कोएफिशिएंट? हर एक का कोएफिशिएंट निकालना है. t raised to 1/1 factorial, t raised to 2/2 fact. Just see what remains. अगर मैंने t square upon 3 factorial में से t square upon 2 factorial अगर मैंने बाहर निकाला तो क्या बचेगा? t cube upon 4 factorial. तो t cube upon 3 factorial अगर मैंने बाहर निकाला तो बचेगा 1/3 या 1/4, which means that अगर यहाँ पे एक 2 है तो यहाँ पे 3 बचता है, यहाँ पे 3 है तो यहाँ पे 4 बचता है, तो अगर यहाँ पे r है तो यहाँ पे बचेगा 1/r plus 1. So now what is mu1 dash? So mu1 dash is 1/1 plus 1, that is 1/2. Mu2 dash is 1/3. And we have to calculate mean and the variance. So mean will be 1/3 and variance is mu2 dash minus mu1 dash the whole square. Once we get mu r dash, we will just substitute r is equal to 1, r is equal to 2. So when r is equal to 1, that is the mean, and then mu2 dash minus mu1 dash the whole square is equal to the variance. So we have 1/3 minus 1/2 the whole square, which is 1/3 minus 1/4, that is 1/12. This is another way of when we cannot put t equal to 0, then we may have to make use of the definition, that is expansion function. Even if that is not possible, then you do the normal method of calculating mu r dash, which is e of x raised to r. The normal method जो करते वो भी दिखा दूंगी मैं यहाँ पे. So normally we differentiate and calculate the moments. अगर possible नहीं है, differentiation is possible, but when we put t equal to 0, we will not get a finite value. In that case only we have to think of this definition, coefficient of t raised to r upon r factorial. So mean is equal to half, variance is equal to 1/12. ठीक है, हमने नॉर्मल वे से m0t निकाला है. m0 ऑफ t में यहाँ पे एक टर्म आता है e raised to t, तो e raised to t के बदले हमने एक्सपेंशन यूज किया है, 1 और -1 कैंसिल हुआ है, and then taking 1/t also inside the bracket, we get this as the expansion. ये expansion में से t raised to r upon r factorial का coefficient निकालना है, and that we got as 1/r plus 1. Then our aim is to calculate mean and variance. Mean is mu1 dash, तो mu r dash हमें पता है, तो mu1 dash हो जाएगा 1/1 plus 1, which is 1/2. mu2 dash is 1/3. And variance is mu2 dash minus mu1 dash the whole square, which is 1/12. Next problem. The random variable x has the probability density function f of x equal to k e raised to minus kx for x greater than 0, k greater than 0 is equal to 0 otherwise. Find the MGF, mean and the variance. अगर डिस्क्रीट रैंडम वेरिएबल दिया है तो x की स्पेसिफिक वैल्यूज दी होंगी. अगर ऐसा दिया है कि x is greater than 0 means it takes all the values greater than 0, not necessarily only integer values, it takes all the values. That is why it becomes a continuous function. So first we have to calculate MGF. Again, it is not specified that we have to calculate MGF about the point or about the mean. So we are calculating about the origin M0 of t. Since x is a continuous random variable, the formula for expected value will become integration. And x is greater than 0 का मतलब हो जाएगा, the limits will be 0 to infinity. F of x के बदले substituting for k also, k into e raised to minus kx. So calculating the MGF or M0 of t, since x is a continuous function, we have integration f of x, substituting for f of x, k e raised to minus kx into dx. K is a constant which can be taken outside the integration. There are two e raised to functions, तो दोनों को combine करके integrate करना है. Now remember here the upper limit is infinity. Okay, since the upper limit is infinity, तो हमें क्या करना पड़ेगा? E raised to minus of some term we have to keep, so that when we apply the upper limit, e raised to minus infinity will become 0. अगर e raised to infinity में रखा तो again it is not defined. So what we have to do is combine these two e raised to functions, but write this as e raised to minus of something, so that when we apply x is equal to infinity, the whole term will become 0. For example, तो इसको मैं लिखूंगी, यहाँ पे लिखूंगी minus of k minus t into x. I will not write t minus k into x. अगर मैंने k तो बाहर आ गया, अगर दोनों को combine किया तो I can also write e raised to t minus k into x. अगर मैंने t minus k रखा तो क्या होगा? जब हम इंटीग्रेट करेंगे और जब हम अप्लाई करेंगे द अपर लिमिट, द होल टर्म विल बिकम इन्फिनिटी. वी वांट अ फाइनाइट आंसर फॉर दैट. इसलिए हम लोग क्या करेंगे? ये माइनस साइन निकालने के बाद वी विल राइट द e raised to function. So we are writing e raised to minus of k minus t into x. Upon the integration of this will become minus of k minus t between the limit 0 and infinity. Then apply the upper limit. तो ये पूरा हो जाएगा e raised to minus infinity, which is 0. E raised to 0 is 1. So we will get the answer as k upon k minus t. ठीक है? तो जब भी e raised to के terms हैं, and if you are having infinity as the limit, then try to write e raised to term as minus of something, e raised to minus something. So that when we substitute that variable as infinity, the whole term will become 0. अगर हमने माइनस साइन बाहर नहीं निकाला तो हमारा आंसर इंफिनिटी में आ जाएगा, which is not possible. Okay, so M0 of t becomes k upon k minus 2. Hello? Yeah? Any doubt anybody is having? Okay, so M0 of t is equal to, okay, I thought somebody wants to ask something. That's what I just thought. M0 of t is equal.
Could you repeat integration part again?
This one? This
Yes.
integration. See, what we are doing is there are two functions of e raised to, ठीक है, k तो constant, we can take k outside. Now we are having two terms of integrate, two functions in terms of e raised to. तो यहाँ पे e raised to tx is there. Here we have e raised to minus kx. So to integrate this, we have to combine e raised to functions. We have to combine e raised to function. अगर हम combine करेंगे तो we can write e raised to m into e raised to n will become e raised to m plus n. So we will get e raised to tx minus kx. ठीक है? When we combine e raised to function, we can write e raised to tx minus kx. So when we take x outside, we will get e raised to t minus k into x. E raised to t minus k into x. अगर हमने t minus k के फॉर्म में रखा, and then when we integrate, so we will get e raised to t minus k of x upon t minus k. And then when we apply the upper limit, तो पूरा term infinity हो जाएगा, because e raised to infinity is infinity. इसलिए हम लोग क्या कर रहे हैं, ये दोनों टर्म्स कंबाइन करने के बाद माइनस साइन कॉमन ले रहे हैं, ताकि when we apply the upper limit, the whole term will become 0. Clear? Any doubt? ठीक है? तो हम क्यों, we can combine as it is also, e raised to tx minus kx करके x को कॉमन निकालो, t minus k लिखो और फिर इंटीग्रेट. that part is okay. लेकिन क्या होता है जब हम अप्लाई करते हैं लिमिट, तो वो पार्ट इंफिनिटी हो जाता है. इसके लिए हम लोग माइनस साइन कॉमन निकालते हैं. That is the reason we are taking minus sign common. So e raised to minus of k minus t into x upon minus of k minus t. ठीक है? Hope all of you are clear in this. तो जब भी e raised to का टर्म आता है और लिमिट्स अगर इंफिनिटी है तो माइनस का टर्म बाहर निकालो, इट बिकम्स 0. पूरा टर्म जो है वो 0 हो जाएगा. फिर खाली लोअर लिमिट बचेगा, लोअर लिमिट का नेगेटिव साइन, और ये नेगेटिव साइन व्हेन x इज 0 ये पूरा 1 हो जाएगा. तो वी विल गेट k अपॉन k माइनस t. पूरा शॉर्टकट में लिख दिया मैंने एक्चुअली द स्टेप्स, दैट इज व्हाई आई थिंक द कंफ्यूजन. ठीक है? सो m0 of t is equal to k upon k minus t. Now calculate. Now can we differentiate, and when we put t equal to 0, are we going to get a finite value? Now m0 of t is k upon k minus t. अगर हम differentiate करेंगे k upon k minus t को t से, and then put t equal to 0, are we going to get infinity answer? या कोई एक फाइनाइट आंसर आएगा. अगर हम इसको डिफरेंशिएट करेंगे तो क्या आएगा, k तो कांस्टेंट है, 1 अपॉन k माइनस t का इंटीग्रेशन हो जाएगा माइनस, और 1 अपॉन k माइनस t द होल स्क्वायर. तो व्हेन वी पुट t इक्वल टू 0, k की वैल्यू रहेगी वहां पे, डिनोमिनेटर 0 नहीं होगा. तो वी कैन अप्लाई द नॉर्मल डेरिवेटिव मेथड. वी हैव m0 ऑफ t इज दिस, कैलकुलेटिंग d by the normal method से हम लोग करते हैं d by dt of m0 of t. d by dt of m0 of t. Again, I've shown you u by v method, that is not required. 1 upon x के फॉर्म में भी हम differentiate कर सकते हैं. I've just shown you u by v, v into du minus u into dv upon v square. The first term is 0, so k upon k minus t the whole square. This is a direct differentiation, but I've just shown you every time you can apply u by v if there is a confusion in the method in differentiation. Now put t equal to 0, that will give mu 1 dash. When t is equal to 0, यहाँ पे t के बदले 0 हो जाएगा, तो k upon k square हो जाएगा 1 upon k. Again differentiate this and put t equal to 0. तो यहाँ पे जब t को 0 पुट कर रहे हैं तो हमारा आंसर इंफिनिटी नहीं आ रहा है. So we can differentiate and put t equal to 0. जहां पे इंफिनिटी आ रहा है वहां पे हमको कोएफिशिएंट वाला पार्ट या अदर मेथड से करना पड़ेगा. So mu 1 dash is 1 upon k. Now calculate mu 2 dash, or differentiating again with respect to t. फिर से मैंने यहाँ पे u by v किया है. Again you need not do that, directly 1 upon x square का डेरिवेटिव लिख सकते हैं. I've applied u by v here. So v into du minus u into derivative of k minus 2 the whole square is 2 k minus t into derivative of k minus t, which is minus 1 upon denominator square. So first term will become 0. We can cancel 1 k minus t, and then we will get the answer as 2k upon k minus t the whole cube. Again put t equal to 0 to get mu2 dash. This method is same what we have done for discrete random variable. So mu2 dash is equal to 2k upon k cube, that is 2 upon k square. Now calculate the variance. So what is the variance? The problem with the continuous random variable is you have to integrate the function. There we have to calculate the summation in the case of discrete random variable. But in the case of continuous random variable, you have to integrate. So sometimes the integration may be difficult or may be complicated. 1 upon k square, correct. So variance will become mean is 1 by k, and the variance is mu2 dash minus mu1 dash the whole square. Mu2 dash is 2 upon k square, mu1 dash is 1 upon k the whole square, which is equal to 1 upon k square. Correct. This method is same what we have done. अगर पूरा आंसर इंफिनिटी नहीं आता है तो we can continue. There is no problem of applying this method. कभी कभी अगर इंफिनिटी जब आता है तब we have to think of the other methods of calculating the moments. So all these derivatives it's not required, you can do directly 1 upon x square का derivative. खाली क्या है k minus t का derivative minus 1 आ जाएगा. Rest everything will remain the same. Next problem. Only find the MGF. Find the MGF of the random variable having PDF f of x is equal to x for x lying between 0 and 1, 2 minus x for 1 less than x less than 2, and equal to 0 otherwise. So calculating only MGF, no mean, no variance, no moments, only calculating the MGF. So calculate M0 of t. M0 of t is e of e raised to tx. As we are given continuous random variable because x is varying between 0 and 1 and 1 and 2. It's not taking the values 1, 0, 1 and 2. It is taking all the values between 0 and 1 and 1 and 2. So which means it is a continuous random variable. So we will have integration e raised to tx into f of x dx. E raised to tx into f of x dx. Substituting for f of x is defined in two intervals. One is 0 to 1, other one is 1 to 2. So writing this integral as 0 to 1 plus 1 to 2. So in 0 to 1, the function defined is x, and in 1 to 2, the function defined is 2 minus x. तो यहाँ पे fx के बदले x, यहाँ पे fx के बदले 2 minus x. So integrate both the terms, apply the upper limit, lower limit, and then find the m0 of t. How do we integrate this? E raised to tx into x or e raised to tx into 2 minus x. कैसे integrate करना है? UV rule. So abhi algebraic and exponential functions we are having. So take the algebraic function as u, e raised to को v लेना है. Then normal जैसा हमने Fourier series में किया वैसे ही हमको integrate करना है both the terms. यूज uv. तो uv के लिए हम लोग सबसे पहले लिखते हैं u इंटेग्रल v. तो फर्स्ट ब्रैकेट में u, सेकेंड ब्रैकेट में इंटेग्रल v. वी हैव टेकन u एज x एंड v एज e रेज टू dx. तो फर्स्ट ब्रैकेट में u लिखा, फिर इंटेग्रल v लिखा. सेकेंड टर्म इज नेगेटिव, x का डेरिवेटिव और ये ब्रैकेट टर्म का इंटीग्रेशन. नेक्स्ट 1 का डेरिवेटिव 0 हो जाएगा. सो वी हैव ओनली 2 टर्म्स हियर. द लिमिट्स आर 0 to 1. यहाँ पे भी 2 minus x को we will keep it as one function, that is algebraic function. तो ये u again integral v minus इसका derivative which is -1, इसका integration that is e raised to tx upon t square between the limits 1 and 2. So applying the upper limit and the lower limit. Applying the upper limit and the lower limit. तो when we apply the upper limit, जब x की वैल्यू 1 है, यहाँ पे हो जाएगा 1 e raised to t upon t, again minus e raised to t upon t square. When x is 0, first term is 0, we will have 1 upon. When x is 2, यहाँ पे आ जाएगा 2 minus 2 0, फिर ये आ जाएगा फिर lower limit. So applying the upper limit and the lower limit. So we will have, पहले x को 1 पुट करना है तो e raised to t by t. यहाँ पे भी x को 1 पुट करना है तो e raised to t upon t square. लोअर लिमिट में की वैल्यू 0 है, ये पूरा टर्म 0 हो जाएगा. यहाँ पे x के बदले 0 पुट करना है, बट दैट्स अ लोअर लिमिट. सो माइनस इंटू माइनस विल बिकम प्लस. e raised to 0 is 1, so 1 upon t square. यहाँ पे 2 minus 2 0 हो जाएगा, माइनस माइनस प्लस e raised to 2x upon t square. And then the lower limit 2 minus 1 is 1. Then x is 1, e raised to t by t, and here e raised to t by t square. Simplify and see what remains. Simplify everything. Some terms may get cancelled. I think e raised to t upon t and minus e raised to t upon t. These two terms will get cancelled. So how many terms remains now? E raised to 2t upon t square, 1 upon t square. यहाँ पे e raised to t upon t square, यहाँ पे minus e raised to t upon t square. So we can combine that. So we can write e raised to 2t upon t square plus 1 upon t square minus 2 e raised to t upon t square. T square is common. So we can take the common and combine the numerator. So we can write the numerator as a minus b the whole square, because we are having a square 2ab plus b square. So writing the common denominator is t square. So numerator, when we combine, this becomes a square, this becomes b square, this is 2ab. So a minus b the whole square. Again, it's all simplification. This part is your answer. This is only simplification. Because now when you have MCQ test, the answer is most important. You should know how to reduce it to that particular answer. When you have a descriptive test, then the steps are okay. But when you have MCQ test, then the final answer is very important. So we got m0 of t is equal to e raised to t minus 1 upon t the whole square. Integration only we have to be careful while doing it, because discrete में summation easy हो जाता है. When we have integration, Portion for the midterm exam is module 1, Laplace transform, inverse Laplace transform, and statistical techniques. That is curve fitting, regression, that three together is called as statistical techniques. Module 1, Module 2, and Module 5 from the syllabus. Okay, we'll discuss about that tomorrow. I'll just complete this portion today and then we'll discuss everything in detail tomorrow and day after. Okay? So 3 chapters to start preparing because MCQ form mein hoga, to start preparing for that. We'll discuss about that tomorrow. Next problem. A random variable x has the following probability density function. Find the MG of x. Again, we have to calculate the MGF. So again, calculating M0 of t. M0 of t is expected value of e raised to tx. Again, as we are given a continuous function, x is varying from -1 to 2. We can write this as integration. I can write -1 to 2 of e raised to tx into f of x dx, but f of x is equal to 1 by 3. Expected value is either summation or integration. So here we have a continuous function. So we are having integration. Whatever is the function inside, that multiplied by f of x in the case of continuous random variable, or in the case of discrete, we have summation this into p of x. So substituting for the limits, x is varying from -1 to 2, fx is 3. So integrating. Now, since the limits are not having infinity in it, we don't have to bother. We can integrate as it is. So 1 by 3 into e raised to tx upon t between the limits -1 and 2. Apply the upper limit and the lower limit. So 1 by 3 into e raised to 2x upon t minus e raised to -t upon t. Or I can write e raised to 2t minus e raised to -t upon 3t. No, actually, when we have expected value, it is varying from it's not 0 to infinity actually. It is varying from minus infinity to plus infinity only. यहाँ मैंने गलत लिखा हुआ है. It is minus infinity here. यहाँ पे not 0 to infinity. हमेशा it can take any values. ठीक है? I have made a mistake over here. Just make a correction. It's minus infinity to plus infinity. कैसे भी x की values हो सकती हैं, either negative or positive. It is not varying always from 0. मतलब कोई भी लिमिट हो, वो लिमिट के अंदर जो फंक्शन दिया है उसको इंटीग्रेट करना है. ठीक है? So make a correction over here. This is minus infinity, not 0. Next problem. A continuous random variable x has the probability distribution f of x equal to this. There is 0 less than or equal to x less than or equal to 3, f of x equal to 0 otherwise. Find MGF and the first 4 moments about the origin. Find MGF and first 4 moments about the origin. फिर से m0 of t निकालना है पहले. As we are given a continuous function, integration of e raised to tx into whatever is the function given, 0 to 3 में e raised to tx. Okay, so whatever is the limits given, that is going to be the upper and lower limit. Four by 81 is a constant which can be taken outside, and maybe x also can be taken inside the second term, so that it will become 9x minus x cube. Now use u into v. Be careful because we have 9x minus x cube. We are having algebraic function into exponential function. So u इंटेग्रल v लिखना है और u को बार बार डिफरेंशिएट करते जाना है, इंटेग्रल v को इंटीग्रेशन. So do that part. Integration. So first u लिखना है, इंटेग्रल v माइनस इसका डेरिवेटिव इज 9 minus 3x square, इसका इंटीग्रेशन, इसका डेरिवेटिव, इसका इंटीग्रेशन, and then इसका डेरिवेटिव, इसका इंटीग्रेशन. Next derivative of minus 6 will become 0, so we can stop with that. Between the limit 0 and 3. Apply the upper limit and the lower limit. Apply the upper limit and the lower limit. When we apply x is equal to 3, we will have 9 into 3, which is 27, minus 3 cube is also 27. First term 0 हो जाएगा. Second term में x के बदले अगर 3 put किया तो 9 minus 27 into e raised to 3t upon t square. Then we have the fourth term will become 6 into 3, which is minus 18, e raised to 3t upon t cube. Then minus into minus 6, e raised to 3t upon t raised to 4. Lower limit mein when x is 0, this term is 0. When x is 0, lower limit ka minus sign and this minus sign will become positive. 9 into e raised to 0 is 1 upon t square. When x is 0, again this is 0. And we have minus into minus plus, lower limit minus, so we get one more minus here. 6 into 1 upon t raised to 4. So simplifying, that is going to be the MGF. We cannot simplify further. Because यहाँ पे e raised to 3t है upon t square, यहाँ पे 1 upon t square, यहाँ पे, so we cannot combine, no like terms here, so we cannot combine any terms, leave it like that. Okay, now इसके बाद हमें निकालना है algebraic, what is that? First 4 moments about the origin, I think. We have to calculate the first 4 moments about the origin. So can we use differentiation method? Can we use d by dt of m0 of t at t equal to 0? We have to calculate mu1 dash, mu2 dash, mu3 dash, and mu4 dash. But when we differentiate this function with respect to t, we will have t terms in the denominator. So when we put t equal to 0, the whole term will become infinity, which means that we cannot calculate the the moments about the origin by differentiating with respect to t. So the other method, now यहाँ पे कैसे e raised to 3t का, we can apply the, what is that? expansion of e raised to 3t. Yeah, directly you can calculate the normal method of calculating the moments. Okay, either you expand e raised to 3t and calculate the coefficient of t raised to r upon r factorial, or directly you calculate mu1 dash, mu2 dash, mu3 dash, etc. So how to calculate mu1 dash? It is e of x raised to r. Okay, it is e of x raised to r, or I can write integration mu1 dash will become e of x. E of x means x into the function f of x. जो भी है वो यहाँ पे आ जाएगा into the function f of x. इसको इंटीग्रेट करेंगे तो mu1 dash मिलेगा. Then mu2 dash, mu3 dash. Okay. So either you use the coefficient of t raised to r upon r factorial by making use of the expansion of e raised to 3t, or we can do directly the normal method of calculating the moments. Hence नहीं पूछा है यहाँ पे, खाली find the MGF and find the moments about the origin. अगर hence पूछा है तो ही हमको MGF use करके we have to calculate the moments. So integrate this. Again, 4/81 is a constant which can be taken outside. This x square can be taken inside. Now integrate this. Integrate this and tell me what is the value of mu1 dash. 4/8 square minus x raised to 4 को integrate करना है. So 9x cubed by 3 minus x raised to 5 by 5. Apply the upper limit, lower limit, and tell me what is the value of this integration. Eight by 5. Okay. What about others? इंटीग्रेट करना है और अप्लाई द लिमिट्स, अपर लिमिट लोअर लिमिट तो जीरो ही हो जाएगा. Just use calci. 9 into 3 cube upon 3 minus 3 raised to 5. 8 by 5. Akshay also is getting 8 by 5. Okay, fine. So mu1 dash is 8 by 5. ठीक है. Next mu2 dash निकालना है. mu2 dash क्या हो जाएगा? E of x square. तो सम इंटीग्रेशन ऑफ x square into f of x. तो नेक्स्ट आ जाएगा mu2 dash which is x square into f of x. फिर से 4/81 कॉमन निकालेंगे, x क्यूब को अंदर ले लेंगे, फिर से इंटीग्रेट करेंगे. 4/81 into 9x cube minus x raised to 5 dx. Again integrating, applying the upper limit and the lower limit. What is the value of mu2 dash? Three. Okay. Nine into 3 raised to 4 by 4 minus 3 raised to 6 by 6. 4/81 outside. Okay, it is equal to 3. Correct. ठीक है, तो यहां पे हम लोग डायरेक्टली कैलकुलेट कर रहे हैं विदाउट यूजिंग द एमजीएफ. We can calculate using the MGF, but we are calculating by the direct method because वो MGF थोड़ा बड़ा हो जाएगा. So we are just neglecting that part so that we can calculate it वहां पे तो e raised to 3t का पूरा एक्सपेंशन लिखने के बाद you have to calculate what is the coefficient of t raised to r upon r factorial. Similarly, mu 3 dash. 4 पूछे 4 moments about the origin. Calculating mu 3 dash and mu 4 dash. Apply the upper limit. Again, lower limit will become 0. 216 upon 35. Okay. शायद right है. Yes, 216 upon 35. ऐसे और एक करना है mu 4 dash. mu 4 हो जाएगा e of x raised to 4. So integration x raised to 4 into f of x. Again 4 by 81 is constant. Taking it out. Take x raised to 5 inside the bracket. Integrating and applying the upper limit and the lower limit. 27 by 2. Okay. (27/2). अगर वो hence word पूछा है तो we have to apply the MGF. अगर नहीं पूछा है you can apply any method of calculating the moments. (27/2). So first 4 moments. अगर उन्होंने पूछा है first 4 moments about the mean or the central moment, then इसका हम लोग formula use करके कि mu1 equal to 0, mu2 is equal to, all these formulas we can apply and calculate that. One more, you can try this. Same way ही करना है. So with this, the portion is over for this semester. We will start with the, so what I will do is this week we will have revision of your midterm portion. And then after the midterm, we will start with the presentation part, mini project. Let us finish off with this midterm test first, and then we will start with the presentation. Now in this question also, they have asked find the MGF mean and variance. So you can calculate mean and variance using any of the method, not necessary from the MGF. If they ask find MGF and hence calculate the mean and variance, then you have to make use of the MGF and then calculate the mean and the variance. तो यहाँ पे भी हमने जैसे पहले क्वेश्चन में किया, दो e raised to के फंक्शन है, ठीक है, हमें कंबाइन करना है, लेकिन वो माइनस साइन बाहर ही लेके करना है हमको. So combine these two in such a way that we get e raised to minus term only. तो पहले मैंने क्या किया है, इसको कंबाइन, खाली x वाले टर्म्स को कंबाइन करने हैं. तो यहाँ पे एक टर्म e raised to 5 बाहर आ जाता है, because that is a constant. फिर कंबाइन किया है e raised to tx और e raised to minus x. फिर से माइनस लेने के बाद I have written 1 minus t into x. Always when you have, and the limits are also infinity, na, because 5 to infinity the limits. So we have to take e raised to minus term outside whenever we have e raised to function and the limits as infinity. Applying the upper limit will become infinity, lower limit will become e raised to 5, raised to 5t upon 1 minus t. इतना ध्यान रखना है कि अगर इंफिनिटी लिमिट है तो e रेज टू माइनस टर्म करके बाकी के फंक्शन लिखूंगा, माइनस ऑफ समथिंग ऑफ x लिखना है तुम्हें हमेशा। e रेज टू जब इंफिनिटी का लिमिट होता है तो e रेज टू माइनस इनटू दिस, अदरवाइज यू विल नॉट गेट अ फाइनाइट वैल्यू, इंफिनिटी आंसर आ जाएगा उसका। ठीक है, नाउ कैन यू कैलकुलेट मीन एंड वेरियंस बाय डिफरेंशिएटिंग दिस, इज इट पॉसिबल? Or do we have to use? Yes, because 1 minus t है, अगर t 0 भी हो गया तो 1 minus 0 is equal to 1, that is fine. We can calculate directly by d by dt, निकालेंगे इसका first derivative, second derivative, calculating the mean and the variance. ठीक है, just you can complete this. Normal differentiation I've done, u by v, and then put t equal to 0. This was a homework problem, I thought of giving it, but then I thought I'll solve it. It is u by v, so v into du minus u into dv upon v square, open the bracket, simplify, we will get this. Now put t equal to 0. When t equal to 0, you will get here 6, here we'll get 1 minus z is equal to 6. So mean is equal to 6. So again differentiating this using u by v and calculating at the point t equal to 0. We get the answer to be 37. So variance is equal to 1. Okay? So once पहले हम लोग अभी क्या करेंगे, we will just wind up with this. Now we will start revising our midterm portions, and then before the end term again we will revise all these things. Okay, so with this the syllabus is over officially. Now we will be continuing with the revision part of your midterm. That is the first, because MCQ होने वाला है तो कैसे questions आएंगे, we will discuss that tomorrow. ठीक है, so thank you for today. See you tomorrow.